Hi, welcome to the second video of my series on Raspberry Pi and getting a fischertechnik motor running via breadboard and transistor. Last time I found out that I had to use the library RaspberryPi in order to get the PWM, pulse width modulation, running, which is needed to get that motor running, and that gives me an unexpected problem. Being that the RaspberryPi setup, pin mode and PWM write are not recognized, despite having the, let me scroll up, despite having the RaspberryPi library nicely included, and it does not give an error on that, so that is yet to be corrected. Another point is that I need at least 9 volts for the motor to run it, despite the fact that I do have a transistor circuit, which I do need to have a motor running. So two tasks: getting the C++ code running, and if you remember from last time, I can't do this in Python because this library is written for C++, and I don't like using wrappers, which means that there's a Python thing built around a C++ or C or whatever code, so I keep it to C++. But the problem with the 9 volts is that the Raspberry Pi gives either 3.3 volts or 5 volts, and neither is 9 volts. And within electronics there is a way to enhance the voltage by using a transistor circuit. So that is one of the options I have. I already tried to put a 9 volts power supply from fischertechnik on it, but then I can't control it from the from the Raspberry Pi, so that option is left out by now. Leaves me doing this first. I want this to be solved. So why is this include not going correct? And last time I did check whether all these undefined references are actually in the RaspberryPi, and it was no surprise that everything is in there. So brings to the question: is everything used the right way? RaspberryPi setup is used the right way. Pin mode is. So maybe a lot of things are in GPIO class, and that hasn't given any problem either. So let's, for correctness sake, check let's go here, look for wiring Pi. Let's go here to the actual code. So wiring Pi setup, and yes, no surprise there, it simply is here. And we pin mode is here as well, and PWM write is here as well. This is a void, yes, and a void is no parameters inside the bracket. Then, so this is correct. Then pin mode should have an integer pin and an integer mode, which is also correct. And another thing would be that PW output should be given, and the question is that the case? Right now I don't see it, but alright, let's check the other one. PMW write should have integer pin and integer value. Integer pin, integer value. So this is a nice one. PWM output. If I on the other hand, it says there are undefined references. So it's not just this, it's the whole instruction that's not found. So I need to look into that. And now we get something interesting, because I looked at an example and it turned out that the example says I have to include the library manually, which means -L wiring Pi, and guess what happens? No error. So now I have an executable motor, and I must be root. Well, no problem there. You must only call this once per program run. Please fix your code. And that's an interesting thing, because I have it, as you can see, in the while loop. So I am going to change this. And I put this here. Now this should be fixed. Alright, second attempt. And I see the LED burning, but as expected, the motor isn't doing anything at all, because the voltage is low, too low, 3 times too low actually, 3.3 against 9. No. So with only LED burning and yes, 3.3 volts voltage, let's go to the voltage amplifier, and let's see if the Ctrl C also works here. That's odd. The LED still burns, and that should not have happened. So that's a point in the code as well that I have to check. But first things first, an amplifier. When I thought about increasing the voltage level, I was thinking about a circuit with resistor and an NPN transistor, but documentation tells me it is not meant for driving a motor. So what does drive a motor? And then I get to the op amp. So I will discard this, and here I have a neutral op amp. Op amp is operational amplifier, and it does increase the voltage. With a feedback, a potential sensor, oscilloscope, and a clock. So the purpose is, oh by the way, I'm using Scilab Xcos simulation again, as you may have noticed, and this is a constant voltage. Since I use a constant voltage of 3.3 volts from the Raspberry, I can also use 5 volts, but for now, for the first test, I'm going to use 3.3 volts. Resistors are all at 220 ohms, since that's the resistor I use. So let's start a test with this. I have to wait for the simulation to go on, and there you see from the 3.3 volts the output is, let's say, 7 volts. Will this be enough? No, I need 9 volts. So I close the simulation and I put this at 5 volts. So let's see how this ends up. Lo and behold, we have a 10 volts simulation, 10 volts output. Now this is just a simulation, and it is not being said that this will go in my circuit, because I have some different amplifiers. But it is a very nice thing to show that this actually delivers a nice voltage amplification. So this is what I will use. And now it's time to actually put up a circuit and see if this indeed does let the motor run. So now we are looking at the actual setup with the transistor circuit still in place, but added is an operational amplifier which has the following connections. This is the input from the transistor, being the pulse width modulation needed to drive the motor. Then the mass, and this is the output which goes to the motor. And then the motor itself has to be connected to the mass as well. And this wire is still connected to the mass of the Raspberry, so that everything that has to be connected to the mass can be simply put in this line. So with all that said, let's run the code. And I also changed the code a little bit so that the pulse width modulation output and the LED should stop burning when the code is stopped. But let's see how it all goes, if something goes anyway. I don't see much happening. I'm stopping it, and indeed now the LED stops burning. So that's one improvement. But the improvement I want to have is not happening yet, which is a motor that is running. So what I am going to do is check the voltage. And for that I of course need a multimeter. Setting it to let's say 30, and then see what I can measure between these two, and that shows unfortunately absolutely nothing. So this would mean that I made an error in the circuit. There's nothing to measure, and when there is nothing to measure, it won't run anyway. So I need to check this circuit, and it may mean that there's a problem in the mass, but I don't think so, because the LED is clearly burning. And I can check that if I remove this wire, it stopped burning. So that's a clear one, and let me replace it by a different jump wire. So this is alright. The point is, what voltage does the pulse width modulation give? And I should measure in this wire, and of course then connect it to the mass. So this one and this one, which surprisingly doesn't show anything either. So there is definitely something to think about on the circuit. How do I set it up? To make things more clear, I have added some wires, and I changed some setup wires. So one thing is that I added a measuring point for the mass. I also added a measuring point for the voltage coming from the transistor. And what I changed is that I changed the input from pulse width modulation to 5 volts. This 5 volt is coming from Raspberry, and the difference is that the voltage of the pulse width modulation is very low. So when I measure the output from the transistor using mass and this output, it is only 2 volts. And while it is necessary to use a transistor to drive a motor, I still need 9 volts here. Another problem, which is more serious, is that the output from the op amp is absolutely zero, which means that even if I had 9 volts here, or 5 volts for that matter, I would have had 0 here, and that is absolutely not going to work. So I would need 2 op amps in that case to put 2 volts to 5 volts and then 5 volts to hopefully 9 volts. But that requires 2 good working op amps. Now this op amp has an input here as well. So what I want to do is using that part, see if it changes anything at all, and that requires some rewiring, of course. And since that is on the other side of the op amp, I'm going to replug. The output will be going here. The mass, the negative, will be going here, and then the output from the transistor will be going here. So with all that, let's run it again, see if that makes any difference at all. And I find I have to start the Raspberry stuff again. For some reason that has ended its run. So let's go, and I have to be root. And here we have a problem, because now although we do have 5 volts, the LED doesn't burn at all. So that's not the intention. Now it does, a wiring problem. But as you can see, even with the rewired op amp, there's nothing to go. So this means and even now I see that LED is not ending. So let me change the voltage back to pulse width modulation and start the program again. The LED burns quite faintly now, but the software works in the case that this is working but the motor doesn't. So this means for now it's the end of this episode. I need to find a working op amp, and preferably two, in order to get things working. So thank you for watching, and to be continued.